So I don't think so I'll be joining the class next Wednesday because I'll be going to India.
Okay, so will you join on Monday?
Yes, I will be joining on Monday.
But
Just on
Wednesday,
Wednesday I will not be joining because and then on 3rd July, no June, I have my NATA exam, entrance exam. So I'll be joining in India. Just next Wednesday I will be absent.
okay, no issues. So any doubts from chemical kinetic solutions?
No, ma'am, no, I don't.
Okay, fine. So shall we start another chapter today?
Yes, can we start organic chemistry?
Fine. Okay, just wait a minute. So we can start with haloalkanes and haloalkenes. Okay.
Okay, ma'am.
Okay, so quickly tell me what are haloalkanes and haloarenes.
Okay,
Do you remember or shall I tell you?
no, I remember. Wait, yeah, they're actually hydrocarbons in which one or more hydrogen atoms have replaced with halogen. Halogens are iodine, chlorine, fluorine,
Okay.
bromine. I'm
Okay,
right?
good. Yes, good.
Okay.
So we have hydrocarbon that is made up of carbon and hydrogen only.
Yeah.
And in which one of the hydrogen or more of the hydrogens, if they are replaced by halogen atoms, they are called as haloalkane.
Yes.
The general representation of haloalkane is Rx. And this X is halogen, which are group 17 elements, right?
Yes. Yes.
It can be fluorine, chlorine, bromine, and
iodine.
okay. So suppose we have taken a simple example, like CH4 is methane. And
Yes.
if we replace one hydrogen atom by an halogen, like we have placed Cl. Now, can you tell me the hybridization of this carbon atom in haloalkane?
You mean you want me to tell me the name of this?
Name as well as the hybridization.
It's chloromethane, right?
Yes, chloromethane. Now tell me the hybridization of this carbon.
I don't know.
Okay. How many single bonds is this forming?
It's forming 3 hydrogen.
3
and
CH bonds
one
and 1 CCl bond, right?
bond, yes.
So if it is forming 4 single bonds, the hybridization is sp3.
Okay, yes.
So you have to remember that in haloalkanes, the hybridization of carbon atom is sp3, okay?
Okay.
And the general name of this haloalkane, it is also called as alkyl halide because this R is alkyl group and halogen is represented as halide. So they are also called as alkyl halides. Okay.
Yes. Yes, I
Okay, fine. Now, if one halogen atom is attached, it is called as monohaloalkane. If two are attached, it is called as dihaloalkane.
Right.
3 are attached, trihaloalkane. So you know this, right?
Yes.
Okay. Do you know the difference between primary carbon, secondary carbon, and tertiary carbon?
Yes. Just a minute.
Yes, tell me.
Mm,
Okay, I'll tell you. See, this is your functional group, that is your halogen, right?
Yes.
Now you have to see the carbon atom which is directly attached to this halogen. Fine. So now you can see that this carbon atom is attached to only one carbon atom, right?
Yes.
So this one is primary. If the carbon atom is attached to only one carbon atom, it is called as
Primary.
primary. Now see, here halogen it is attached to this carbon atom, and this carbon atom is further attached to two carbon atoms. So it will be secondary. Fine.
Yes.
And now this one, the Cl is bonded to this carbon, and this carbon is further attached to three carbon atoms, so it will be tertiary, 3 degrees.
Yes.
Okay, so you should know. Okay, now tell me what are geminal dihalides. Dihalide means two halogen atoms are attached. So you should know the difference between geminal dihalides and vicinal dihalides.
When both hydrogen atoms are present on the same carbon atom,
It is called,
geminal halides.
yes. In this, the halogen atoms are present on same carbon atoms, and in this, it is present on different carbon atoms. So if I take the example like this, CH3, CHCl2. So you can see that both the halogen atoms are present on this carbon atom.
Yes.
And if I take the example CH2, CH2, Cl. So you can see that the two halogen atoms are present on adjacent carbon atoms.
Yes.
So it should be actually adjacent carbon atoms. That is understood.
Yes.
Okay. Now do you remember allylic halide?
Yeah. Wait. Allylic. Wait, it is a halogen atom which is bonded to sp3 hybridized.
Are you reading from the book?
No, it's in my notes.
Okay, so you have your notes in front of you.
Yeah.
Okay. See, there's a doubly bonded carbon atoms, right? CH2 double bond CH.
Yes.
And the carbon next to this double bond, if halogen it is attached to this carbon atom. Now you can observe that this carbon atom is making 4 bonds, one with carbon, one with halogen, and two with hydrogen. So this carbon is sp3 hybridized. Okay, so we say that
Yes.
if the halogen atom is bonded to the sp3 hybridized carbon atom, which is adjacent to the carbon-carbon double bond, then we call it as allylic halide. Okay, so the carbon atom next to the doubly bonded carbon atoms is called as allylic carbon. So this one is allylic carbon because it is present next to the carbon-carbon double bond. Is it fine?
Yes.
Now tell me, which type of halide is this?
It's allylic halide.
Yes, because it is the halogen is present on the carbon which is next to the carbon-carbon double bond. So this will be called as your allylic carbon.
Okay.
Now, what about benzylic halide? Yes. So if the halogen atom is directly attached to the carbon present on a benzene ring. So benzene ring has a carbon CH2 and to which the halogen atom is attached.
Okay.
So this is your benzylic halide. And again, this carbon to which the halogen is attached, it is making 4 bonds, one with this carbon, one with the halogen, and two with the hydrogen. So it is also sp3 hybridized.
sp3.
So you should remember the hybridization also. Now tell me, what are vinylic halides? Do you remember?
Yeah, it's the same like allylic halides, but with double bond, right?
Like in this, the halogen atom is directly bonded to the doubly bonded carbon, like this. And in allylic halide, the halogen atom was attached to the carbon which is present next to the doubly bonded carbon atoms. And here it is directly bonded to the carbon-carbon double bond, right? So the carbon to which halogen is bonded is this one. Now, can you tell me the hybridization of this carbon?
It's sp2 hybridized carbon.
Yes, because it is making 3 single bonds. So it is sp2 hybridized. Now, next is aryl halide. Aryl halide are also called as haloarine. Okay. The chapter is haloalkanes and haloarenes. So the other name of haloalkanes is alkyl halides, and the other name of haloarenes is aryl halides. So you should remember the general names also, right?
Yes, ma'am.
So it's haloarene. So if the halogen atom is directly bonded to the benzene ring, it is called as haloarene or aryl halide. Now, can you tell me the hybridization of this carbon to which the halogen is attached?
You mean in aryl halides?
Yes, this one.
It's sp3.
No, it's making 3 single bonds, 1, 2, and 3. So it
Oh,
will be
sp2
sp2.
hybridized.
So in hybridization, you only count the single bonds, right?
Yes.
Okay. Now, if I talk about dihaloarenes, haloarenes are in which halogen is directly attached to the benzene ring. So, first position, this is your second position. So 1, 2 position is called as ortho. Fine. So these are ortho to each other. If the 2 halogen atoms are present like this, like first position, second and third. So they are present on first and third position. So they are called as meta.
Yes.
And if they are present like this,
Para.
so they will be called as 1, 4 or para. Right?
Yes.
So you should remember these forms.
Yes. Okay.
Now next we'll discuss about nature of CX bond. Like in haloalkanes or haloarenes, the halogen atom is bonded to carbon, right?
Yes.
And you know that the electronegativity of halogen is more than that of carbon.
Yes.
The electronegativity of halogen is greater than that of carbon. So halogen atoms will attract the electrons towards itself, right?
Yes, ma'am.
So it will have partial negative charge and carbon will have partial positive charge, right?
Yes.
That means we can say that this CX bond is polarized bond. It is polar bond because of the electronegative difference.
Yes.
Carbon has a partial positive charge and halogen has a partial negative charge. So we can say that the carbon halogen bond is polar in nature.
Okay.
Okay, and you know that in group 17, there is fluorine, chlorine, bromine, and iodine, right?
Yes.
And you know that when we go down the group, size increases or decreases?
It increases.
Yes, so when we go down the group, it increases. That means your fluorine atom is the smallest and iodine is the largest, right?
Yes.
So this is the smallest and this is the largest. So if we talk about the carbon halogen bond length, so which will have smallest bond length? Which bond? CF bond, CCl bond, CBr bond, or CI bond? Which will have smallest bond length? See, the size is smallest of fluorine.
Yes.
And bond length simply represents, see, this is carbon and if this is fluorine. So bond length represents this distance, right?
Yes.
So If fluorine is the smallest, that means CF bond will have the smallest bond length, and then the size will increase. So the bond length will also increase.
Increase. Okay.
Because iodine is the largest and fluorine is the smallest. So as the size of the atoms increases, bond length also increases. Is it clear to you?
Yes, ma'am.
Okay. So you should remember the bond length. Next is preparation of alkyl halides. Alkyl halides are your haloalkanes.
Yes.
Preparation of haloalkanes. And the representation is Rx. So do you remember any method to prepare alkyl halides?
Yes, from alkenes.
How?
Wait, how? Addition of hydrogen atoms.
By addition of
Hydrogen.
halide.
Oh, yes.
So first we'll discuss how to prepare haloalkanes from alcohols. Okay.
Yes.
So alcohol is represented as ROH, right?
Yes.
And if we have HCl in the presence of ZnCl2, it will get converted into RCl, alkyl chloride, and along with it, water will be formed. There are
Okay.
many ways to prepare alcohols, to prepare haloalkanes from alcohols. So first reagent is HCl and ZnCl2. Next, if we can take NaBr and H2SO4. So in this, OH will be replaced by Br. So it will form RBr, and the byproducts will be NaHSO4 plus H2. Next, we can have phosphorus trihalide. So 3ROH plus PX3, that means it is trihalide. So it will form 3RX plus H3PO3. Next reaction we can have with pentachloride of phosphorus, PCl5. So here Cl will be attached, so it is RCl plus POCl3 plus HCl. Now if we have ROH along with it, red phosphorus and X2. X2 is your halogen molecule, so it will form RX. And the most important method in this is if
Thionyl chloride.
what did you say?
Thionyl chloride.
Yes, we have the reaction with thionyl chloride, SOCl2. So this is important. Thionyl chloride. So here you'll get RCl. Along with it, you'll get sulfur dioxide and HCl. And you know that sulfur dioxide and HCl, both are gaseous substances. So here two gaseous products are formed. And you know that gases can escape from the mixture, right?
Yes, ma'am.
So they'll escape from the mixture and we'll get pure alkyl halide.
Okay.
Okay, so this reaction is preferred because alkyl halide is formed along with SO2 and HCl, and both are gaseous products, so they'll escape from the mixture and it will give pure alkyl halide. So this one is very important. So remember this, okay?
Okay, ma'am.
Okay, so these were the preparation methods of haloalkanes from alcohols. Now, tell me whether these methods are applicable for the preparation of aryl halides. Tell me whether these above methods are applicable or not. Yes?
Yes.
No. See, in aryl halides, You
Yes.
can see the halogen atom is directly bonded to the benzene ring, right?
Yes.
And you know that halogens have lone pair of electrons.
Yes.
And these electrons can shift here. This can
Okay.
shift here. That means resonance is involved, right?
Yes, ma'am.
And when you draw the resonating structure, we can draw like this. This will gain negative charge, and here it will be positive charge. Yes or no?
Yes.
So you can see that carbon and halogen is having a partial double bond character. The CX bond
6 1. Yes.
is having partial double bond character. Okay.
Okay, ma'am.
So these methods, they are not applicable for aryl halides.
Okay.
See, in this we were using alcohols, ROH. So here we'll talk about phenols. By mistake I wrote X. So here will be OH because we'll prepare from phenol,
Yes.
right?
Yes, ma'am.
So oxygen will have two lone pair of electrons, right?
Yes.
Oxygen has two lone pairs. So here the carbon oxygen bond will be having partial double bond character, right? So these methods are not applicable for the preparation of haloarenes or aryl halides because in phenol, carbon oxygen bond is having a partial double bond character and which is difficult to break. Because in comparison to single bond, double bond is difficult to break, right?
Yes, ma'am.
Because single bond is and double bond. So double bond is more stronger. So that's why it is difficult to break. Is it clear?
Yes, ma'am.
Okay, so the next type of reaction is free radical halogenation. Do you remember free radicals?
Yeah. Wait. Free radicals.
The species having unpaired electron like this, Cl free radical. Remember, this unpaired electron
Yes.
species are called as free radical.
Free radicals. Yes, I remember.
So suppose we have the compound CH3, CH2, CH2, CH3, and we are reacting it with chlorine. And this free radical mechanism takes place in the presence of light, that is H mu. So it takes place in the presence of light or heat. Now tell me, this carbon is primary or secondary?
It's secondary.
No, this carbon is attached to only one carbon
One
atom.
currency is primary. Yes.
What about this one?
This one is also primary.
Yes, and what about this middle ones?
These ones are secondary.
Because they're attached. Okay.
Two.
So we have two options for the products. We can either replace this carbon atom primary, hydrogen from this primary carbon atom, or we can replace hydrogen from the secondary carbon atom. So we'll get the two products. One will be CH3, CH2, CH2, Cl, and the other one will be CH3, CH2, CH, Cl, and CH3. Right?
Yes.
So these two are the possible products. Now tell me which one will be the major product?
Excuse me, ma'am. Your voice is coming twice.
Twice.
Yes, 2 times. It's
Right
breaking.
now?
Yes.
Okay, fine. Just wait a minute. Is it okay now?
Yes, it's fine.
So for how long was it coming twice?
It's secondary, right?
Yes, this is. I was asking since how long it was the voice was coming twice.
No, it was only for just now, just this
Okay, okay.
free
No issues.
radical hallucination. Yeah.
Okay. Now tell me which one will be the major products. So this is your primary and this is your secondary. So which will be major?
It will be secondary,
Yes, because secondary free radicals are more stable.
more stable. Okay.
So this will be your major product. So this is how free radical hallucination is done. So next we'll start the preparation of haloalkanes from alkenes, which you were telling in the beginning, right? Now tell me, how do you prepare haloalkanes from alkenes? Yes, Rufia, can you hear me?
Yes.
So there are two methods to prepare haloalkanes from alkenes. First one is the addition of hydrogen halides. Do you know what are hydrogen halides? Rufia, do you know what are hydrogen halides?
No.
Okay. So halides, you know? Halide
Yes.
is fluoride, chloride, bromide, iodide. So these are in general called as halides. And
Yes.
hydrogen is simply H plus.
Yes.
So HF, HCl, HBr, and HI. These are called as hydrogen halides.
Okay. Okay.
HF is hydrogen fluoride, HCl is hydrogen chloride, HBr is hydrogen bromide, and HI is hydrogen iodide. So in
Okay.
general, they are called as hydrogen halides. Okay.
Okay. Okay.
So we can convert an alkene into an alkyl halide. That means an haloalkene by reaction with hydrogen halide. So we can use HCl, we can use HBr, we can use HI. So to convert alkenes into alkyl halides, we have to make them react with hydrogen halides.
Okay.
Right? So
Yes.
do you remember any rule which is used to form the products? Alkene is getting converted to alkyl halides. So we
Yes.
use
Yes. It's something with Markov.
Markovnikov.
Yes. Yes.
Okay. Do you remember the statement?
No.
Okay, I'll tell you. So you have the substrate. This is alkene, you have the substrate. So suppose we have taken the example CH3, CH double bond CH2. Fine. What is
Yes.
the name of this compound?
Okay. Wait. You mean this entire compound?
Yes, this one. CH3, CH double bond CH2.
It's wait. It's um.
See, it has 3 carbon atoms, so it will be prop. And it has double bond, so it will be ene. So it is simply propene.
Oh my God. Yes.
So it is so simple. So if we react it with HCl, you know that HCl is H plus and Cl minus, right?
Yes.
So Markovnikov rule states that the negative part of the adding molecule, so these are your adding molecule, HCl, HBr, HI. So negative part of the adding molecule goes to that carbon atom which is having lesser number of hydrogen. So you have to see the doubly bonded carbon atoms.
Yes.
And
Yes.
this is your adding molecule. So the negative part of the adding molecule will go to that carbon atom which is having lesser number of hydrogen. So it is having 1 and it is having 2. So negative part will go to that carbon which is having lesser number of hydrogen. Understood?
Yes.
So it will be CH3,
CH.
CH, Cl, and this H plus will go to this carbon atom having more hydrogens. So it will become CH3. Is it
CH.
okay?
Yes. Yes.
So this is your major product.
Yes. Major product.
The other product will be that Cl will go to this carbon atom, which is having more hydrogen.
Or hydrogen, yes.
So the next product will be CH3, CH2, CH2, and Cl.
Yeah.
So this is your minor product. So this way, two types of products are formed, and major product is decided by the Markovnikov rule.
Okay.
Okay. Have you
Yes.
understood?
Yes, yes, I have.
Okay. So next is the second part, the second method to prepare from alkenes, that is addition of halogens.
Okay.
So you have a doubly bonded carbon atoms, that is you have having alkenes. So what is the name of this alkene?
Wait.
It is two carbon atoms with a double bond. So it is ethene.
Ethene, yes.
Okay. So now you are making it, the alkene react with bromine. Do you know the color of bromine?
Yeah, it's brown, reddish brown.
Yes, so it is reddish brown. So when you react with this alkene with bromine, you'll observe that this bromine atoms will add to the two carbon atoms.
Carbon atoms, yes.
So it will form like this. CH2 single bond CH2, and along with it Br will be added to both the carbon atoms.
Yes.
So it is an example of dihalide, right? Because two halogen atoms are present
In
and
adjacent carbon.
an adjacent carbon atom. So it will be called as vicinal dibromide. Okay.
Okay, ma'am.
Now you can see that earlier the bromine was having reddish brown color, and when you added bromine to an alkene, it will result in discharge of reddish brown color. So after the reaction, the reddish brown color of bromine will disappear because bromine has been used in the reaction, right?
Yes, using
So
reaction.
this reaction, it is used for detection of double bond in a compound. So if the double bond will be present, it will react with the bromine atoms and it will form vicinal dibromide, right? So it is used for detection of double bond in a molecule. Is it okay?
Yes, ma'am.
Because the reddish brown color will be discharged after the reaction. This you have to remember.
Okay.
Okay, so do you remember any name reaction from this chapter?
Wait, name reaction means
The special name of the reactions like Finkelstein, Cannizzaro, aldol condensation,
yes, I remember them.
Getaman. So any name reaction for this from this chapter?
Finkelstein.
Yes, that I told you. One
Wait,
more.
there is one more with G.
It is Schwarz reaction.
Yeah, and Sandmeier's reaction also.
Yes, yes.
Sandmeier's is from a mind.
So first we'll discuss about halogen exchange reactions. So in this, two types of reactions are there. One is Finkelstein and the other one is Schwarz reaction. So one by one we'll
Nucleophilic
discuss.
substitution also comes in the reaction, right?
Yes, but that is not a name reaction.
Okay, okay.
So we have Finkelstein reaction first. So in Finkelstein reaction, you have an alkyl chloride or bromide. So here X can be Cl or Br. So you have alkyl chloride or bromide and you make it react with NaI. NaI is sodium iodide. Okay.
Yes.
And you react them in the presence of dry acetone. And here the halogen will get exchanged and it will form Ri. So R will combine with I and
Yes.
NaX.
X. Okay. Yeah.
So in this reaction, you have to remember that alkyl.
NaX.
Yes, sorry. So So in this reaction, you have to remember that alkyl chloride or bromide reacts with sodium iodide in the presence of dry acetone, and it forms alkyl iodide. So you can see that halogen is getting exchanged. So it comes under the category of halogen exchange reaction. Okay.
Okay.
Now next one is your Schwarz reaction. Do you remember it?
Which one?
Schwarz reaction.
Yeah, I remember it.
See, in Finkelstein reaction, we have prepared alkyl iodide. In Schwarz reaction, we'll prepare alkyl fluoride. So you should remember, always remember the product. So in this, alkyl fluoride will be formed. So we have taken an alkyl chloride or bromide in the presence of metallic fluoride. So suppose we have taken the example CH3Br. So this can be your alkyl bromide or chloride, anyone you can take. And you have to react this with metallic fluoride. So suppose we have taken the metallic fluoride, AgF.
Yes.
So you have to take the metallic fluoride. So other examples of metallic fluoride you can remember. That is, apart from AgF, we have HgF2, we have COF2, and we have SbF3. So in this reaction, we have taken AgF right now. And now you can exchange the halogens now. So CH3 will combine with F. So it will form CH3F, and Ag will combine with Br. You can see here that halogen exchange is taking place. Okay.
Okay. Okay, ma'am.
So if alkyl iodide is formed, we call it as Finkelstein reaction. And if alkyl fluoride is getting formed, we call it as Schwarz reaction. So these are the two name reactions under the category of halogen exchange.
Okay.
Okay, so you have to remember this. Next is your Sandmeier's reaction.
Yeah,
Do you remember that?
Yes, I remember that.
Okay, tell me.
It is to synthesize aryl halides from aryl diazonium salts.
Yes, benzene diazonium salts.
Yes,
So what do we take in this reaction?
we take wait we usually take
So first we'll take a primary aromatic amine. Amine, do you remember NH2 group?
yes, NH2 group, yes.
So you take primary aromatic amine. So suppose we have taken NH2. What is the name of this? It is called as aniline. Remember?
Yes, yes, I
So it is
remember.
an example of primary aromatic amine. And now you react it with sodium nitrite, that is NaNO2 plus HCl, right?
Yes.
And the temperature range is 0 to 5 degrees Celsius. Or in Kelvin, you can say 273 to 278 Kelvin. So you should remember the temperature change in this 0 to 5 degrees Celsius. Now, what will be the product? So it will get converted into benzene diazonium chloride. So this reaction is very important.
Okay.
So that when aniline is treated with sodium nitrite and HCl or any acid, HX, HBr, HI, so benzene diazonium halide will be formed. And here it is benzene diazonium chloride.
All right.
Okay.
Okay.
Now, if you further react this diazonium halide, so we are writing just the general form. If it in case of HCl we took HX, then the product would have been N2 plus and X minus, right?
Yes.
So it will be called as benzene diazonium halide in general, if X is there. So now if you react this benzene diazonium halide with Cu2X2. So in place of X, it could be Cu2Cl2 and it could be Cu2Br2. So these are the two possible options, Cu2Br2 and Cu2Cl2, okay?
Okay.
It is called as cuprous chloride or cuprous bromide. Cuprous means that the valency of copper is +1. Fine. So copper +1 valency is called as cuprous. So in
Yes.
this we can take either cuprous bromide or cuprous chloride. And then this halogen atom X, it will be attached to the benzene ring. So if you are reacting it with Cu2X2, so the N2 plus X minus will be replaced by X. So we'll get an aryl halide.
Okay.
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 So you have to remember that when aniline is treated with sodium nitrite, see, aniline is primary aromatic amine, benzene having NH2 group. So
Yes.
if it will be treated with NaNO2 and HX in general, and you should remember the temperature range 0 to 5 degrees Celsius, then NH2 will get converted into N2 plus and Cl minus. And this is called your benzene diazonium halide, X minus if we take N2 plus X minus. And now if you treat this diazonium salt with cuprous halide, cuprous is your +1 form, the valency is +1. So if you treat it with cuprous chloride or cuprous bromide, so it will result in the replacement of this N2 plus group, this diazonium group with Cl or Br. So this halogen atom will come here. That means it will result in the replacement. Okay.
Okay, ma'am. Okay.
So this way aryl halide can be synthesized using primary aromatic amine. So this is very important. So this is your Sandmeyer reaction. So this way we can prepare chlorobenzene, we can prepare bromobenzene, right?
Yes, ma'am.
Now, if you want to prepare iodobenzene, so we have got this benzene diazonium halide, that is N2 plus X minus by the above reaction. Now, if you treat this benzene diazonium chloride with Ki, Ki is potassium iodide. So if you treat this with potassium iodide, it will result in the formation of iodobenzene. So this way we'll get iodobenzene and we get chlorobenzene or bromobenzene by Sandmeyer's reaction. Fine. So this you have to remember.
Yes, ma'am. Okay.
And
Okay.
here nitrogen gas will be released because N2 is getting out. And here also nitrogen gas will be released when this is formed because N2 group is getting replaced. Fine. So have you understood this?
Yes, ma'am.
Okay. Now, if I give you one question. So we have an alkene attached to the benzene ring and we are making it react with HBr. Now tell me what will be the product of the reaction? Which rule is used here?
Uh,
Can you see we have alkene here
yes.
and here we have hydrogen halide, right?
Yes, it's Finkelstein rule.
No. In Finkelstein, we had this sodium iodide and triacetone.
Yes.
here we have alkene, along with it hydrogen halide is present. So here Markovnikov rule will be followed. See,
Yes, ma'am.
so if we have alkene and HCl, HBr or HI, alkyl halide will be formed and Markovnikov rule will be followed. This is important.
Okay.
Don't forget this.
Okay,
So,
ma'am.
so here Markovnikov rule will be followed, and you know that in Markovnikov rule, negative part of the adding molecule goes to that carbon atom which is having lesser number of hydrogen, right?
Yes,
So these are the two carbon atoms. Which one is having lesser number? Carbon 1 or carbon 2?
it's carbon 2.
It's carbon 1 because carbon 1 is having only one hydrogen and
Yeah.
carbon 2 is having two hydrogen.
Yes.
So negative part of the molecule adds to that carbon atom which is having lesser number of
Yes.
hydrogen. And this double bond will get converted into single bond. So here we'll have 3 hydrogen now. And here one hydrogen was already present and here bromine will be attached. So this is your product. Understood?
Yes, ma'am. Yes.
This you have to remember how the substitution takes place, how it is getting added. That negative part of the adding molecule has to go to that carbon atom which is having lesser number of
Yes.
hydrogen. Okay.
Okay.
Now if I give you one more example, so just CH3, CH2, CH double bond CH2 plus HCl. Now again it is alkene with hydrogen halide, right?
Yes.
So where will the chlorine atom be attached?
It will, wait. It will attach in CH2 after CH3.
Which carbon atom from the left hand side?
Wait, from left, it's second.
This one or this one or this one?
The second one,
This
CH2.
one? This
Yes.
one? No, I told you that whenever we have alkene and this hydrogen halide, so the negative part will go to that carbon atom of the double bond, which is having lesser number of hydrogen. So you have to see these doubly bonded carbon atoms. And
Yeah.
the one having lesser hydrogen, chlorine will get attached to it. That
Okay.
means the product will be CH3, CH2,
CHCl,
CHCl, and hydrogen will get attached there. So it will become CH3.
H2.
Okay.
Yeah, okay.
See, the carbon having lesser hydrogen,
Yes, yes.
negative part will attach there. And positive part will go to the carbon having more hydrogen.
More hydrogen.
Understood?
Okay. Yes, ma'am.
So, do you remember anti-Markovnikov rule?
No.
So it's,
Anti.
yes,
No.
it's just the opposite of Markovnikov rule. So in Markovnikov rule, the negative part was getting added to the carbon having lesser hydrogen, right?
So it will go to the which has greater.
Yes, right. So
Okay.
negative part will go to that carbon atom which is having more hydrogen atoms.
Okay.
And for anti-Markovnikov rule reaction, peroxide should be present along with hydrogen halide. So you have to remember that whenever peroxide is present along with the hydrogen halide, you have to apply anti-Markovnikov rule. And if peroxide is absent, you have to apply Markovnikov rule. Fine.
Yes, ma'am.
So I'll give you one example to explain. So we have benzene ring, then we have CH2, CH, double bond CH2, and the reaction is with HBr, and along with it, peroxide is present. So you can see that peroxide is present, so you will apply which rule?
It's not.
Anti-Markov. Because peroxide is present. I told you that whenever peroxide is present,
Yes,
you
it's
have
my
to apply
anti-Markovnikov.
on it. So how will you form the product? You just have to see the carbon atoms which are doubly bonded. Rest will remain same.
Okay.
So it will be CH2. This will remain same. Now tell me the product.
C.
Okay.
C.
Now see, this negative part will go to which carbon? Which is having more hydrogen, right?
More hydrogen, yes.
So it will go to this one carbon, the
Yes,
last carbon.
CH2, the last one.
That will become CH2Br, right?
Okay, okay,
And
okay.
hydrogen will go to this carbon atom, which is having lesser hydrogen now, just
Sir.
opposite of the previous one. So it will become CH2. So CH2, CH2, CH2 and Br.
Okay.
Understood?
Yes, yes, I understood.
Okay, fine. So next we'll discuss about physical properties.
Okay.
So what comes under physical properties? Melting point, boiling point, solubility, right?
Yes, density. Yeah.
Yes. So if we have the same alkyl group, we are keeping the alkyl group same, and we have different alkyl halides, like we have RF, we have RCl, we have RBr, Ri. That means alkyl fluoride, alkyl bromide, alkyl chloride, alkyl iodide. Fine.
Yes.
So for the same alkyl group, with increase in mass and with increase in size, the force of attraction between the molecules increases. So if the force of attraction is increasing, the molecules will have higher boiling point. So we can see that iodine is the maximum in size
Yes.
and it has the maximum mass. So the boiling point of iodine will be the largest, then of alkyl bromide, then alkyl chloride, and the least is of alkyl
Fluoride.
chloride.
Alkyl
So
chloride.
this you have to remember. It is the order of boiling point.
Okay.
And you know that boiling point is directly proportional to the surface area,
Yes.
and
Boiling.
it is inversely proportional to the branching. That means if branching is there, boiling point will decrease.
Degrees. Okay.
I'll give you examples to explain this. So we have CH3, CH2, CH2, Br. In this, all the carbon atoms are in a straight line, right?
Yes.
This one is having branching, one branching. This one is having two branches, right? One above, one below.
Yes.
Okay, can you tell me the names of all the three compounds?
Okay, okay, okay. It's bromobutane. First one.
Yes, correct.
And this is wait, three, it's second one.
You can see that bromine is present on the second position, 1, 2.
Yes.
So it will be called as 2
Two
bromo.
bromobutane. Yes.
And this is 1 bromobutane or simply bromobutane, right?
Yes.
And this one. This is your main chain. 3 carbon atoms. First, second, and third position. So you can see that on second position, bromine is also attached and CH3 is also attached. So the name is 2-bromo, 2-methyl, and the main chain is having 3 carbon atoms, so it will be propane.
Propane. Yes.
It's 2-bromo, 2-methyl propane. Now you can see that in the first compound, all are arranged in the straight line. In second one,
Yes.
there is 1 branching, and third one, it is 2 branches.
Two branching.
And you should know that boiling point is inversely proportional to branching. That means if the branching increases, boiling point will decrease, right? Yes or no? Because
Yes,
they are
ma'am.
inversely proportional to each other. So if this is your compound 1, this is your compound 2, and this is your compound 3. So which one will have maximum boiling point?
Compound 2.
It will be 1, the one arranged in a straight line. All the atoms are in a straight line.
Okay.
So it will have maximum surface area. And you should know that with increase in branching, the surface area reduces. It's like this. So it is getting reduced. And now with increase in more branching, it attains the shape of a sphere. Can you see in the third compound? It is
Yes,
attaining
yes.
the shape of sphere. So it is having least surface area now. So that's
Okay.
why it is have the minimum boiling point. So first one will have the maximum boiling point, then the second one, and then the third one.
Third
Because I
one.
told you with increase in branching, boiling point will
Boiling point decreases.
decreases. Yes. So you can do these types of questions, right?
Yes. Yes.
Okay. So now if I talk about dihalobenzenes. Dihalobenzenes means that 2 halogen atoms are present on the benzene ring. Fine. So we have ortho form 1, 2. We have meta form 1, 3, right? And we have para form 1, 4. So it is ortho, meta, para. You should be clear with this that ortho is 1, 2 and meta is 1, 3 and para is 1, 4. Now, which one of these will have highest melting point? Have you studied about this?
Um.
Okay, tell me which one is more symmetrical.
Ma'am, can you just wait 1 minute? Just 2 minutes.
Sure.
So sorry. Yes, ma'am.
Okay, tell me which one is more symmetrical, which is having more symmetry.
It's it's para.
Yes, it's para. So you have to remember that in dihalobenzenes, and you know that all these are isomers of each other, right?
Yes.
You know what are isomers?
Yes, yes. I know our isomers.
Okay. So the boiling point of all these isomeric dihalobenzenes are nearly same. But now we have to talk about melting point. So the melting point of para form is the highest. So you have to remember it has high melting point as compared to ortho and meta forms. And the reason is because of the symmetrical structure.
Structures. Yes. Okay.
So because of the symmetrical structure of para form, it fits in the crystal lattice better. So it fits in the crystal lattice better than ortho and meta forms. Right? So this you have to remember that para form is having highest melting point. Fine?
Okay.
And the boiling point of all these will be nearly same. Very small difference will be there. Okay.
Okay, ma'am.
Now, if we talk about density, so you should know that with increase in the number of carbon atoms, with increase in the number of halogen atoms or the mass of halogen atoms, density will increase. So if there are more carbon atoms, density will increase. If there are more halogen atoms, density will increase. And it will also depend upon the mass of halogen atom. So if the mass is more, density will be more. Okay. So this way you can do the order of density. Next is chemical reactions of haloalkanes. Any doubts still here?
No, ma'am, no.
Okay. So chemical reactions of haloalkanes. Do you remember the type of reactions which haloalkanes show?
Chemical reaction of haloalkanes. Yeah, it's a nucleophilic substitution.
Yes.
And elimination reactions.
Yes.
And reaction with metals.
Yes. Are you looking somewhere and then speaking?
No.
Okay. So you told correct. First is nucleophilic substitution. Next is elimination reaction. And third is reaction with metals. Okay, tell me the difference between nucleophiles and electrophiles.
Uh,
Do you remember?
no, I don't remember.
Okay. So there are two species. One is nucleophile and the other is electrophile. The difference should be clear. Nucleophile and electrophile. So if we have an electron-rich species, we call it as nucleophile. So nucleophiles are electron-rich species and they want to attack the center, which is electron deficient. So you can see Cl minus, it is having octet complete, 8 electrons, right?
Yes, ma'am.
So it is an example of nucleophile. If we talk about electrophiles, they are electron deficient species.
Okay.
So if we take the example of BF3. So the structure of BF3 is like this, trigonal planar, right?
Yes.
How many electrons are surrounding boron atom?
3.
Electrons. One bond
Okay,
constitutes 2
electrons.
electrons. So it will be 6 electrons.
6 electrons, yes.
So it is electron deficient or electron rich?
It's electron deficient.
Yes. So it is an example of electrophiles. So nucleophiles are electron rich species and electrophiles are electron deficient species. Okay.
Okay.
And you know that positive attracts negative, right?
Yes.
So one which is electron rich, that will attack at the part which is electron deficient, right?
Yes.
So first we will discuss about nucleophilic substitution. So the reaction in which one nucleophile is replaced by another nucleophile, that is called as nucleophilic substitution. That means one is taking the place of the other. That means it is substituting the other nucleophile. So it is called as nucleophilic substitution. Fine.
Okay, ma'am.
So nucleophilic substitution. So we have alkyl halide, that is Rx, and we have a nucleophile which is attacking it. And I told you that carbon halogen bond in an haloalkane is polarized, right? Carbon has
Yes.
partial positive charge and this has partial negative charge.
Negative charge.
So this nucleophile is electron-rich species. So it will attack at the carbon atom which is having positive charge. So it will replace this nucleophile. So now it will form RNU and X minus
X.
will be released.
Okay.
You can see that the existing nucleophile is replaced by another nucleophile. So this is called as nucleophilic substitution.
Okay.
The substitution reaction is taking place, and this halogen atom is leaving the molecule. That's why it is called as leaving group. Okay. And X minus is called as halide. X2 is called as halogens, and X minus is called as halide ion, like fluoride, chloride, bromide, iodide.
Okay.
Okay. Is it clear?
Yes, ma'am.
Okay. Okay. Now, do you know ambident nucleophiles? Ambident. Okay, tell me the formula of cyanide.
Cyanide. Wait.
Cyanide, Cn minus, remember?
Yes.
So it is having two nucleophilic center. It can attack through carbon as well as nitrogen. So cyanide is Cn minus. It can attack through carbon as well as nitrogen. So it is having two nucleophilic centers.
Okay. Yes.
So groups like this, which are having two nucleophilic centers, they are called as ambident nucleophiles. So the first example is of cyanide, and the next example is of nitrite.
It's NO2 minus.
Yes, the nitrite is NO2 minus. So here it can attach the compound through nitrogen or oxygen. Okay.
Yes,
So
ma'am.
such type of nucleophiles which have more than one nucleophilic center, they are called as ambident nucleophiles. And you should remember at least two examples, that is cyanide and nitrite. Fine.
Okay.
Okay. Now there are two types of nucleophilic substitution reactions. Do you remember? SN1, SN2. Do you remember SN1, SN2?
SN1. Yes, yes, I remember.
Okay. What do you remember?
SN1 is wait. S substitution nucleophilic.
Unimolecular.
Yes, unimolecular. SN2 is substitution nucleophilic biomolecular.
Yes, good.
Okay.
So just you should remember that SN1, substitution nucleophilic unimolecular, takes place in the presence of polar protic solvents. You know the word polar? That means it is having electronegativity difference.
Okay.
And protic means it should have hydrogen ions. So SN1 reactions takes place in the presence of polar protic solvents. And the examples of polar protic solvents is water, alcohol, acetic acid. Okay.
Okay.
Now, do you know the formula of all these? Water is H2O.
H2O.
Yes. Alcohol.
Alcohol is C2H6O.
General representation is
Yes.
ROH.
Okay.
Okay. And acetic acid is?
CH3COOH.
Yes, correct. So you have to remember this, that it takes place in polar protic solvents. And it follows first order kinetics. Remember first order?
Yes, yes.
That means it depends only on the concentration of one reactant. And that reactant is alkyl halide. So it depends on the concentration of alkyl halide only. It does not depends upon the concentration of nucleophile. Fine.
Yes, ma'am.
So it takes place in two steps. This you should remember. Just simple points about it. It takes place in two steps. In the first step, suppose we have an alkyl halide, CH3, CH3, 5. So we
Yes.
have alkyl halide and we have the nucleophile OH minus. So this reaction will take place in 2 steps. So in the first reaction, this carbon and bromine bond will break. This is your step 1. So CH3, CCH3, CH3 and Br. So in the first step, this cleavage of bond will take place and it will form CCH3, CCH3. Now you know that bromine is more electronegative, right?
Yes.
So bromine will have negative charge and carbon will have positive charge.
Positive charge.
So when this bond will cleave, this carbon atom will gain positive charge and bromine will gain negative charge.
Okay.
A species having a positively charged carbon atom is called as carbocation. Remember?
Yes, ma'am.
Carbon having positive charge is called as carbocation. Now tell me, it is 1 degree carbocation, 2 degree or 3 degree?
It's 3 degree.
Yes, so it is tertiary carbocation. So you have to remember that this cleavage, this reaction occurs in 2 steps. So in step 1, this polar bond, the bond between carbon and halogen will undergo cleavage, and this is a slow step. And I told you that the slowest step in the reaction is called as the rate determining step, right?
Yes, ma'am.
So it is your RDS. And in this, the carbocation is produced and the bromide ion is produced. Now, in the second step, this carbocation will be attacked by our nucleophile. So what was our nucleophile? It was OH minus.
Yes.
So this carbocation will get attacked by nucleophile. So CCH3 plus OH minus, it will form CCH3, CH3, OH. So did you understand the steps?
Yes, ma'am. Yes.
Okay, so there are 2 steps, and first step, the cleavage of carbon and halogen atom will take place, and it is a slow step, so it will be the rate determining step. And in the second step, the carbocation is attacked by the nucleophile, and then the carbon and nucleophile bond will be formed. Okay, so this is a fast step. And I told you in kinetics that the rate determining step determines the rate of reaction. So we can say that the rate of reaction depends only on the concentration of alkyl halide, I told you.
Yes, ma'am.
It does not depend on the concentration of nucleophile. It is independent of nucleophile. So if it is depending only upon the concentration of one reactant, we call it as first order reaction. That's why we have written that SN1 reaction is following first order kinetics. And RDS also determines the molecularity of the reaction. So you can see in the slow step, only one molecule is participating, right?
Yes, ma'am.
So that's why we have called it as unimolecular. Understood? So it is substitution nucleophilic unimolecular. Have you understood?
Yes, ma'am.
Okay. Now in this reaction, the intermediate which is forming, that is carbocation. So greater the stability of carbocation formed, greater the reaction will take place. The faster will be the speed. So tell me, which carbocation is the most stable? 3 degree, 2 degree or 1 degree?
It's 2 degree.
It's 3 degree.
Okay, it's 3
So
degree.
tertiary is more stable than secondary. Sorry.
And then, okay.
And then it is primary. Fine.
Okay.
So greater the stability of carbocation, greater will be the ease of formation. That means more easily the product will form. So you have to remember that SN1 reaction will be the fastest in tertiary halides. Okay.
Okay.
The tertiary halides will show faster speed, then of secondary halides, and then of primary halides. Because tertiary carbocations are highly stable.
Highly stable. Okay.
Understood?
Okay, ma'am.
So this was about SN1 reaction. Now you have to remember that in allylic halide and benzylic halide. You remember these two we discussed in the starting?
Yes.
Benzylic halide. So in allylic halide, it was like this: CH2 double bond CH, CH2 and Cl, right? This type was
Yes.
allylic halide. Now,
Halalic.
if this bond will get broken, it will get cleaved. So what will be formed? CH2 double bond CH and CH2 positive, right?
Yes.
So this is called your allylic carbocation
Okay.
and it is highly stable. So allylic halides will also show a great reactivity in SN1 because these carbocations are stabilized through resonance. This bond will shift here and it will form CH2 plus CH double bond CH2, right?
Yes.
So this bond is, sorry,
Stable.
this carbocation is stabilized by resonance. So this is highly stable carbocation and the
Yes.
carbocation which is highly stable that shows greater reactivity in SN1, right?
Yes.
So you have to remember this, that allylic halide is highly stable. And
Okay.
next is benzylic halide. I told you benzylic halide is benzene.
Benzene.
So when CH2 is present and X is attached, halogen is
Isis.
attached. So when carbocation will form, it will be CH2 positive, right?
Yes.
This is your benzylic carbocation. And you know that in this resonance is possible. This bond will shift here. So it will form, it will be double bond CH2 and here plus charge will come. Then this bond will shift here. Here positive charge will come. And then this bond will shift here. That means this carbocation is also stabilized through resonance.
Resonance. Okay.
So you should remember that allylic halides and benzylic halides, they show high reactivity towards SN1 reaction
SN1 reaction.
because the carbocation formed is stabilized by
Stabilized by
resonance.
resonance.
And you should remember the resonating structures, how to draw them. Fine, so practice that
Okay.
also. And last thing is the reactivity of alkyl halide, Rx. So Ri will be the maximum, will show maximum reactivity because it
Yes.
has a maximum bond length. So it can easily cleave. So then it will be RBr, and then it will be RCl, and then it will be RF. So the maximum size will have maximum bond length, right? And you should know that bond strength, the strength of the bond is inversely proportional to bond length. So if the bond length is large, bond strength will be less. And if the bond strength is less, we can easily cleave that bond, right? We can easily break that bond. And then only the carbocation will be formed. Yes or no?
Yes, ma'am.
Okay, so that's all for today's class.
Okay.
Any doubts?
No, ma'am.
So we have covered a major part of this chapter. So you
Yes.
have to revise, practice the naming nomenclatures also, revise allylic halides, benzylic halides, vinylic, aryl halides, geminal, vicinal, the reaction.
Okay.
Okay.
Okay,
And the
ma'am.
name reactions, Markovnikov rule, anti-Markovnikov rule, that is important. And the reaction of thionyl chloride, that is also important. Sandmeyer's reaction, order of boiling point, that means within branching, boiling point decreases. This you should remember.
Okay,
And
ma'am.
SN1 reaction. So all these topics you should revise very well.
Okay.
And rest we'll do in the next class. Fine. So
Okay.
you'll join on Monday, right?
Yes, I will join on Monday.
Okay. So please join on time.